Hi everyone. In today's lesson, we're going to talk more about verifying equations. This time, we're going to talk about a concept called breaking up fractions. So we have here a fraction, x plus 4 over 5. We know that we could break that up into x divided by 5 and 4 divided by 5. So we can write this as x over 5 plus 4 fifths. Those are equivalent statements. Why? Because if I were to add these two together, doesn't this add back to this? If the denominators are the same, you keep it the same and loosely add the tops, right? You can't necessarily add x and 4, but we write it as x plus 4. So this is a concept that we use a lot in trigonometry. We could break up this fraction the same way. This divided by this plus this divided by this. So sine of x over cos of x plus cos of x over cos of x. We know that sine over cosine simplifies to tangent. And we know that anything cos divided by itself is 1. So when we break up the fraction, it could help us simplify. Same thing with this example here. We're going to break up cosecant of x over this whole denominator plus secant of x over this whole denominator. So cosecant of x over cosecant of x secant of x plus secant of x over cosecant of x secant of x. So now we can simplify each of the fractions separately. Cosecant divided by cosecant is 1. Secant divided by secant is 1. So we're left with 1 over secant. And then we're left with 1 over cosecant. Which 1 over, we always know, means the reciprocal. So 1 over secant is actually equivalent to cos. And 1 over cosecant is actually equal to sine. So this simplifies that expression. So what I'd like you to do now is try to see if you can verify this expression, or equation rather, by breaking up the fraction into two pieces, kind of like what we did before, and see if you can get this side. I'm going to say this is the more complicated side. Again, try to use pencil, and then tomorrow we can go over this one in class. All right, let's go on to the next page. Okay, finding common denominators. So this all stems back from these rational expressions that we've been doing this all along. So these are not like terms in the denominator. So the only way we're going to make them the same is by multiplying them by each other. So this needs an x plus 3, and this needs an x plus 3. This needs an x minus 3, and this needs an x minus 3. So we have x minus 3, x plus 3. As our common denominator. And we're going to multiply this times 2x. So we can distribute the 2x in. So this would be 2x squared minus 6x. Here we're going to distribute the 7x in. So 7x squared plus 21x. And then when we make the common denominator, we keep it the same. And we just simply add the tops. So a couple of like terms here. I have my x squareds that I can add together. And I also have my x's that I can add together. So the green ones, 2x plus 7x is 9x squared. And negative 6x plus 21 is going to be positive 15x. And I think we could factor this a little bit more. 9x squared plus 15x. I think I could take out a GCF of 3x. And we'd be left with 3x plus 5. Now I did that just in case I could cross something off here, but I can't. So I actually can just erase that and say, okay, that's not necessary. And we can leave our answer just like this in this form. Okay, so we can find a common denominator with trig as well. So it's okay that there's a cosine. It makes it a little bit more tricky to look at, but it's the same concept. This here needs a 1 plus cos x. Whatever I do to the bottom, I have to do to the top. And this one here needs a 1 minus cos x. So my common denominator is simply going to be 1 minus cos x and 1 plus cos x. Now, I didn't break it up into two fractions here because we're just multiplying it by 1. So I can just go ahead and put those in the numerator. So it's just 1 minus cos x plus 1 plus cos x. My like terms here are that these can cancel, and I'm just left with 2. So 2 over 1 minus cos x and 1 plus cos x. All right, same thing for this last one here. The common denominator here would be that this needs cosine of x plus 1. Whatever I do to the bottom, I have to do to the top. And here, this just needs a sine x. Whatever I do to the bottom, I do to the top. So my common denominator is sine x times cos x plus 1. So here, sine x times sine x is sine squared. And here we're going to double distribute. Now you should notice that these are conjugates. I know we spoke about that a couple lessons ago. So you only need to multiply the first and the last with conjugates because those middle terms will cancel. So cos times cos will give you cos squared. And -1 times +1 will give me a -1. So my common denominator is sine x times cos x plus 1. And I can't really add anything on the top, so I'm just going to write it out as sine squared plus cosine squared, and then -1. And if we simplify a little further, we notice that this is a Pythagorean identity here. Sine squared plus cosine squared is actually equal to 1. And then you can see that 1 minus 1 actually gives us 0. So if we have 0 divided by sine x cos x plus 1, really this whole thing simplifies to 0. So what I'd love for you guys to do right now is try to see if you can do this next one here. Verify using common denominators. You're going to put your line by the equal sign, and you're going to see if somehow you can get this to equal this. All right, so come in with those two problems, at least attempted, and then we will definitely go over those in class tomorrow. All right, that's it for today. If you have any questions, now is a good time to jot them down. Otherwise, I will see you in class tomorrow.